So in this video, we're going to take a look at the last three questions from the new TSI practice exam. So for the first question, question 13, we're told that the yard behind Cindy's house is rectangular and has a perimeter, so that's the sum of all the linear distances around the outside of 72 feet. If the length of the yard L is 18 feet longer than the width, so it's longer than it is wide by 18 feet, what is the area of the yard in square feet? So this is one you definitely want to draw a picture of. You have a rectangle. You don't know its width. You don't know its length either, but you know its length is 18 feet more than its width. So what we're given is that the actual perimeter is 72 feet, and again, that the length is 18 feet longer than the width, and we want to find the area. But remember, the area is the length times the width. So really, in order to do that, we need to know the width and the length. Well, how are we ever going to be able to solve for that? Well, we know if you add up the width plus the length plus the length, you get 72 because that's what the perimeter is. How can we simplify this equation where we can actually solve it since we can't solve for two variables with one equation? Well, we substitute in that the length is just 18 plus the width. So if you do that, you get the width plus 18 plus W plus 18 plus W equals 72. You can combine like terms and you get 4W plus 36 equals 72. How do you solve for the W? Well, begin by solving or isolating the 4W, subtract 36 from both sides. You get 4W equals 36. In order to isolate W, divide both sides by 4, and you get that W is equal to 9. Now, if you know the width is 9, what is the length? Well, remember the length is 18 feet more than the width. 18 plus 9 is going to be 27. So we know the width is 9 and the length is 27. Now, how will we go about computing the actual area? Well, the area is just the length times the width. We know that the width is 9, the length is 27. If you multiply those two things together, you get 243 square feet, which actually turns out to be the answer C. So let's look at question 14 now. The table above shows the high temperature last Thursday for 5 different cities. So we have 5 data points. We're told that if the median of the high temperature was 81, which of the following could not have been the high temperature for the one we don't know? So if you take this data set and you find its median, if we don't know one number, what can't that number be such that the median is 81? And it sounds really confusing, but let's just take the 4 data points we have and let's order them. So I put them in order here. And the temperatures going from decreasing to increasing, or in increasing order from least to most, are 62, 81, 87, and 93. And there's one that we don't know that we have to slide in here. But what we're asking ourselves is where can we slide it, or where couldn't we slide it, if the median temperature turns out to be 81? So let me ask you something. If you picked an additional number to go to in this data set, as long as it was less than 81, it's going to go over here on the left, right? Then you'd have 2 on the left of 81, 2 on the right of 81. 81 would be in the middle, and it would be the median. So you're going to be okay. 81 is going to be your median as long as you pick a value of temperature that's less than 81. So let's look at what these temperatures are. 75, 65, 55. So the key thing is you can't pick 85, because if you pick 85, you're going to have a number over here on the right, like in the case of 85. 85 actually becomes your median value. It's right there in the middle. Remember, median is the number in the middle of the ordered data set. So answer A is the only one that you couldn't pick that would, it's the only one that you could pick, rather, that would make the median not 81. So the answer here is A. Final question, let's look at number, it should say 15, not 20, but there are 20 children in the cast of a class play. 8 of the children are boys. Of the boys, 4 have speaking parts. And of the girls, 8 do not have speaking parts. If a child from the cast of the play is chosen at random, what is the probability the child has a speaking part? So how would we compute the probability that a child has a speaking part? We'd have to take the total number of children in the play, and we'd have to find out what portion have speaking parts. So that's really all that we have to do. We know there are 20 students in the play. We have to count how many have speaking parts. And we got a bunch of information. We know there's some boys that have it, there's some girls, and so on. Here's how I'd approach this problem. I just bullet every piece of information you're given. 20 total children. There are 8 boys, which means there's 12 girls. There are 4 boys that have speaking parts. We were given that directly. We were told that 8 girls don't have speaking parts. Well, since there's 12 girls, that means that 4 do. So we know that of the actual boys, 4 have speaking parts, and of the girls, 4 do as well. So when we compute the probability of any student in the play having a speaking part, the number of people that have speaking parts is just the number of boys plus the number of girls. So in total, there's 8. There are 8 possible ways you can get a speaking part, and there are 20 total kids in the play. So the probability by definition is 8 over 20, which can be reduced to a fraction in lowest terms to 2/5, which is actually answer A for this. So I know I went through those kind of quickly, but hopefully you can look back at the solutions I wrote, which I'll post as well, and be able to figure out kind of the approach for each of those problems.